Hi, in this video, we're going to talk about solving more of exponential equation and logarithm. And we go over a few examples here, and also we're going to talk about solving inequality of exponential as well. Okay, so it's not a long video. All right. So here I do have an example here. Sometimes they just give you a really it look complicated, but they just ask you to find k here. And as you can see, log 2 of 3 is just a number. It's a constant that I don't know. And log 2 of 6 is a constant. Okay. So what we do, we just solve it normally. Just imagine if you have 8 equal k times 4 plus 1. You would to solve for k, you just need to move everything over. So it's a similar idea like this. What I do first is I'm going to plus 1 here. I'm going to minus 1 on both sides. I would have log 2 of 6 minus 1. The 1 go away equal k times log 2 of 3. And then you just treat log 2 of 3, it's just a number, and there's a times here. Opposite of times is dividing, so you're going to divide by log 2 of 3 to the other side, and this will go away. All right, so you will end up having k equals this. Now, the only problem left over is, are we able to simplify this? Now, to simplify this, you can combine log 2 of 6 minus 1 together. So 1, if you want to make into log 2, 1 is log 2 of 2. All right, so we're going to rewrite 1 as log 2 of 2. So log 2 of 6 minus k equal log 2 of 6 minus log 2 of 2 over log 2 of 3. Okay. Then we can combine the log together. This is take away the log. When we combine, we divide them. So it's 6 over 2 over log 2 of 3. And then 6 divided by 2 equal 3. So we can write that as log 2 of 3 divided by log 2 of 3. And luckily, they're the same number, so that we cancel themselves, and it give you 1. So k equal 1. Now we do another example. Here we will have 2x equal 11, and we don't know the value of x. So we talked in previous video that to solve for x, you need to get rid of 2, and 11 you cannot make into the base of 2. That's why you log 2 on both sides. So imagine you do log 2 on both sides like that. Log 2 and 2 will go away. You will have x equal log 2 of 11. And you can put that on the calculator to know exactly what they are. But to estimate them, think about log 2 of 2 equal 1. Log 2 of 4 equal 2, right? Because 2 squared equal 4. Log 2 of 8 equal um, 3, because 2 to the power of 3 equal 8. So 11 will give you 3 point something. That's how I know. But I just don't know, is that 3.1 or 3.2 or what? We have another example here, which is pretty much the same thing. Now, 28 cannot make into the base of 3. So what we do, we're going to log 3 on both sides like that. So log 3 of 3, we cancel them itself. So we have 2x minus 1 equal log 3 of 28. Then you plus 1 over 2x equal log 3 of 28 plus 1. Okay. Then you divide it by 2. So there you go. So x equal log 3 of 28 plus 1 divided by 2. All right. Now, the last thing I want to talk about is solving inequality equations. Before I do this example, I want to emphasize on the few thing. If you have 2 to the power of x bigger than 8, so 2 to the power of something bigger than 8, you would have 2 to the power of 8 is 2 to the power of 3. So you would have x is bigger than 3, right? That's simple. But this time, if I change the base to a smaller number, so let's say I change the base to a half. So think about if I have a half of x, a half to the power of x bigger than 4, for example, okay? Then a half is 2 to the power of negative 1, okay? And then to the power of x bigger than 4. So 2 to the power of negative x bigger than 4. 4 is 2 squared. So because the 2 and the 2 cancel out, negative x will be bigger than 2. Can you see that? And because it's a negative, and you learn in lower year that the negative, when you see the negative, you divide by negative 1 on both sides. And because you divide it by a negative number, they actually switch the side. So this become that way now. So you would have end up having x less than 2 divided by negative 1 is negative 2. So you can see the whole process. If the base is less than 1, I actually change the answer, have the side switch them around. So how does that work if we use the log one? So if we start this equation again, a half of x bigger than 4. Let's say I keep the base the same, okay? I didn't change the base. So I would have x here. And because you want to get rid of a half, so think about you log of a half on both sides. So a half log a half will go away. And you can see the answer change to the opposite side. So you would have x less than log a half of 4. And if you think about what is log a half of 4, which is basically negative 2. Okay, because a half to the power of negative 2, that gives you 4. So x less than negative 2. So what's the key lesson to take away here? If you have, let me just write this down, sorry. If you have a to the power of x bigger than b, and if a is the base is bigger than 1, then you solve for x and the size stay the same. So x will be bigger than log a of b. But if the base is less than 1, so the base is between 0 and 1, and you don't have a negative base, by the way. So the size will change. So x will be less than log a of b. Okay. Here I do have an example here. So 0.7x bigger or equal 0.3. I can see the base is less than 1 is 0.7. So what I do is I log 0.7 on both sides. Okay. And because I log of the base less than 1, I need to switch the sign. So bigger becomes smaller. I would have x is less than log 0.7 of 0.3. There you go.